Good
Hello.
evening, ladies and gentlemen, and welcome to the first ICRAR lecture thing. We haven't come up with a cool space name for this yet, but I'm sure we will come up with one in the future. My name is Greg Robotham. I'm one of the science communicators at ICRAR. Just so you those who don't know, ICRAR is an equal joint venture between the Curtin University and the University of Western Australia. It stands for the International Centre for Radio Astronomy? Yeah, I can't say the word. Astronomy Research. We play a key role in the international, the collaboration of the International Square Kilometre Array project, which will be the world's biggest ground-based telescope array built right here in Western Australia and in the Karoo Desert in South Africa. We're also attracting some of the greatest researchers from around the world working on scientific and technical programs for the SKA Square Kilometre Array, I just mentioned, the Australian SK Pathfinder and the Murchison Wide Field Array, amongst many others. We're also being supported by Astro 3D, which is the ARC Center of Excellence in All-Sky Astrophysics in 3 dimensions, and unifies over 200 world-leading astronomers to understand the evolution of matter, light, and elements from the Big Bang to the present day, combining researchers from not all, but many universities across Australia. But enough of this. The person you've come to hear about is Dr. David Gozzard. David, hello.
Hello, thank you for having me.
No problem at all. Can you please give people just a quick potted history on who is Dr. David Gozzard? Where did you come from? Where are you now? And where are you going?
So I'm from Perth, Western Australia. I am now in Perth, Western Australia. So I did a PhD building part of the Square Kilometre Array telescope at ICRAR. And then I disappeared off to Canberra for a couple of years to work at the Australian National University, shooting lasers at things. And now I'm back shooting lasers at more things for astronomy research.
So you get to shoot lasers at things and you get to call yourself a doctor as well. That sounds like the best job in the world.
It's good fun.
So today, what do you think you'll be talking about? What do you know you're going to be talking about? I'm sure you're not just guessing.
Well, so today I am talking about Pluto, everybody's favorite little dwarf planet.
Aha. I'm hoping that people in the audience will be fighting about this very soon, whether it's a planet, dwarf planet, planetoid, world, whatever it is. We'll find out, I'm sure. Now, for our listeners and watchers at this time, basically, you can ask questions in the YouTube chat, I do believe, and our wonderful moderators will check out those questions and we'll send them to David probably during the talk, more closer to the end, though, please. We'd rather them at the end, so then David can use his giant brain to answer them for you and not have to be sidetracked. So leave your best questions to the end. We'll do our best to get to as many as we can. I think basically I'm going to get the nod from our technical people. Technical people, shall we go ahead? Yep, we're going ahead. Nothing can stop the science train. David, please take it away.
On we go. So there seems to be a lot of love for Pluto out in the community. So this talk is going to be about Pluto itself, the history of humanity's understanding of Pluto, how we found it, how we found out about it, and what we know about it. So the story of Pluto starts with this bloke. This is Percival Lowell. He was an American mathematician, astronomer, writer, who set up his own observatory out in Arizona. And unfortunately, he's often remembered for his astronomy failures rather than his astronomy successes. One of his successes was he was one of the first people to realize we should probably set up observatories out in the desert where it's dark and away from cities, so there's not all this light pollution interfering with our telescopes. But what he's more famous for is that image in the top right hand of the screen. That is his drawing of Mars that he saw through his telescope. And this is towards the end of the 1800s and the 1880s, 1890s. Around that time, there was a lot of Martian fever. Astronomers had started to see features on Mars that they thought might be canals constructed by Martians who lived there. And so this is Percival's map of those Martian canals. But of course, if we look through a telescope today, we don't see any of these canals. So what happened? Well, at the time, Percival had the largest refracting telescope in the world, so a telescope that uses lenses rather than mirrors. And so what scientists think happened is that the light from Mars came down the telescope, bounced off the back of Percival's eye, back up the telescope, and then reflected back into his eye. working as a giant ophthalmoscope. So what we're seeing here is Percival's own drawing of the blood vessels at the back of his eye. Amongst the other things he's known for is working towards the discovery of Pluto. So that big blue, almost featureless orb down in the bottom right-hand corner of the screen, that is the planet Uranus. After Uranus was discovered, astronomers mapped its orbit and found there were perturbations in the orbit. And so a French astronomer, or mathematician and astronomer called Leverrier, computed that this should mean there's another planet out beyond Uranus. And exactly where he predicted that planet should be, some German astronomers found Neptune. But as the decades rolled by, there were still slight errors in the orbit of Uranus. And so Percival did the calculations and worked out that this could be explained if there was another planet about 7 times the mass of Earth out beyond Neptune, which he called Planet X. And he spent the last couple of decades of his life trying to find this Planet X. Unfortunately, Percival passed away in 1916, but he bequeathed his fortune to his observatory that he'd set up to continue running. Now, the problem is there were several legal battles with Percival's widow who tried to keep the money, and eventually, so that stalled the hunt for Planet X for many years. And so it wasn't until 1929 that the hunt for Pluto or Planet X resumed. And the job was given to this bloke. This is Clyde Tombaugh, and he's standing next to a telescope that he built himself in this image. So Clyde was given the job of photographing the stars in the area of sky where Percival had calculated Planet X should be. And the way he did this is he takes an image, star field, so just basically a bunch of stars through the telescope, and then he waits a few nights and takes another image of that same group of stars. And he compares them in a device called a blink comparator. Now, human eyesight is actually very good at working out movement in an image. So if you take 2 images of a star field where the stars don't move, a planet will move through that star field. So if you put these 2 images in a device called a blink comparator and blink back and forth, one then the other, you can see if there are any dots that move from one image to the other. And so these are the images that Clyde Tombaugh took. Now, it's very hard to find free versions of these pictures without the helpful little arrow. You can probably all guess what the helpful little arrow is pointing to. So this is one of Clyde Tombaugh's images. And a few nights later, he took this image, same star field, same area of sky. And as you can see, the helpful little arrow and the dot it's pointing to has moved. If you compare the 2 images, you can see all the stars are in exactly the same place, but this one little dot has moved across the night sky. Clyde then took follow-up images, several more images, nights and months apart, and eventually pinned this down. Yes, this is moving. This is an object in orbit around the sun. Clyde had found a new planet, and it was exactly in the area of sky where Percival Lowell predicted Planet X should be. This was Planet X. They announced the discovery to the world, and it was sensational. This was the first planet ever discovered in America, not in Europe, in the old world. And there was great pressure on them to name it. Now, the naming of planets is a very formal and serious and sober affair. We've got things like Mercury, Mars, Jupiter, the old gods. So we need names like that. So the staff at the observatory went to Constance, Percival Lowell's widow, and asked her for a suggestion of the name for this Planet X. And Constance suggested Zeus. And they said, well, no, you can't have Zeus. That's the same as Jupiter. It's already taken. So then Constance suggested Percival. And they said, well, we can't really name a planet Percival. It's got to be something godlike and ethereal. So then Constance suggested Constance. At this point, they stopped asking Constance, and an 11-year-old schoolgirl from England called Venetia Burney suggested Pluto. And the staff at the observatory loved this. It was perfect. Pluto is the god of the underworld. It's perfect for a cold, distant planet and in the depths of the solar system. And PL, Pluto, are Percival Lowell's initials. It works brilliantly. They unanimously voted for Pluto, and Pluto became the name of Planet X. And it was loved. This is why Mickey Mouse's dog got called Pluto, because of the sensation around this planet. And when elements following uranium, neptunium in the periodic table were found, it was called plutonium to keep in order. So Percival Lowell had calculated that this planet should be 7 times the mass of Earth in order to pull on Uranus as much as it should be. And it very quickly became apparent that this planet is not that big. Once you have the orbit of the planet, you can work out how far away from the sun it is. So once you know how far away it is, you can then get an estimate of how big it is simply from how bright it is. And it's a very small, very dim little planet. And so it was very quickly revised down to about 1 times the mass of the Earth, and then down to about 1/10 the mass of the Earth. And then a few years later, when they realized, hold on, this is so far out in the solar system, it's going to be covered in nitrogen ice. Nitrogen ice is even whiter and more reflective than ordinary water ice, like at the South Pole. So they realized this is actually very, very bright. So using that fact, they revised its size and mass down again to less than 1% the mass of Earth. A good fix on the mass of Pluto came in 1978. In 1978, James Christie, an astronomer, was taking higher resolution or images of Pluto, and he noticed in this left image of the planet a lump on the top right-hand side. And over days, this lump would go away and then reappear again. Pluto had a moon. It just couldn't be resolved perfectly with the telescopes of the time, but Pluto had a moon. Once you've got a moon, you can find out from its orbital period how long it takes to go around the planet, how heavy the planet is. And this greatly reduced the estimated mass of Pluto down to 1/650th the mass of the Earth. And James Christie was asked to name his discovery, this moon of Pluto. And he tried to call it Charlene, after his wife. And he was told, no, you've got to give it something godlike and ethereal, something mythological. It can't be called Charlene. So he named it Sharon, a mispronunciation of Karen, the boat master of the underworld. So that's why a lot of scientists will pronounce the moon Sharon rather than Karen, because it's named after Charlene. There's a reason astronomers don't get to name things anymore. Anyway, so now we had a mass of Pluto that was 1/650th the mass of the Earth. We knew how long its day was. Its moon is so heavy compared with the planet that they are locked facing each other in what's called a tidal locking. So we can see that the moon goes round every 6 days and 9 hours. So that meant Pluto's day length was 6 Earth days and 9 Earth hours. So if this planet is 1/650th the mass of the Earth, what happened to that 7 Earth mass planet that Planet X should have been? Well, that wasn't fully resolved until Voyager 2 flew past Neptune in the late 1980s. When Voyager 2 flew past Neptune, scientists were able to get a much finer, much better estimate of its mass. And they refined the mass of the planet down by 0.5%. Now, 0.5% doesn't sound like much, but Neptune is a gas giant. It's a very big planet. 0.5% of its mass is like losing a whole Mars. So that was where the missing perturbation in the orbit of Uranus was. It was that the mass of Neptune had been overestimated. Once you took that away, there was no need for a Planet X. So why had we found Pluto? It was just luck. It happened to be in the patch of sky where they were looking for Planet X. Now, it took decades before anyone sent a probe to Pluto. Voyager 1 was originally meant to go to Pluto. The Voyager mission was planned as this grand tour of the outer solar system. Voyager 2 would go to Jupiter, Saturn, Uranus, and Neptune, while Voyager 1 would go to Jupiter and Saturn and then sprint out off to Pluto. But NASA changed that idea. They thought that the moon, Saturn's moon Titan, would be a far more scientifically interesting body to go and look at than Pluto. And so the probe never went to Pluto. They had to choose one or the other. They weren't on the same trajectory. They had to bin Pluto. Over the decades since Voyager, various missions started getting funding and started doing design studies for a probe that would go out to Pluto, but due to cost and the amount of time involved in getting to Pluto, and the fact that no one thought Pluto would be terribly scientifically interesting, these probes were all eventually canned. Until that is, New Horizons got up, and New Horizons was built, building on a lot of the work that had been done before for the previous design studies. And New Horizons was launched in January of 2006 on a trajectory for Pluto. When it was launched, it reached a speed of 58,000 kilometers per hour. It's the fastest probe ever launched away from the Earth. To try and put that in some sort of perspective, the Apollo astronauts took about 4 days to get to the moon. New Horizons passed the orbit of the moon in 9 hours. At 58,000 kilometers an hour, you'd certainly be done for speeding on Earth. In Western Australia, I think you'd get a $1,000 fine and several demerit points on your license. Though you'd have a bigger problem in that if you tried to do 58,000 kilometers an hour in your car, you would be vaporized instantly, leaving a crater about 20 meters across. So you got bigger problems than the fine on your hands. On its way out, New Horizons was sent to Jupiter to get a gravitational assist, a slingshot from Jupiter that added more speed to its outward transit to Pluto and boosted it to a speed of about 84,000 kilometers per hour. Still moving at those incredible speeds, it took nearly 10 years to get to Pluto. So New Horizons was launched in 2006 and got to Pluto in 2015. In August of 2006, there was a meeting of the International Astronomical Union where they redefined what a planet was, and Pluto got demoted to be a dwarf planet. Why did this happen? Well, Pluto was simply the first of a bunch of objects out in this region beyond Neptune that we now call the Kuiper belt. It was just the first and largest that was discovered. There are trillions of objects out in the Kuiper belt, and there are several we've found that are comparable in size to Pluto. And statistically, we haven't been able to search the whole Kuiper belt yet. There should be about 100 Pluto-sized things out there. And this is not the first time this had happened. If you were going to school in the mid-1800s, you would have been told that there were 12 planets because things like Ceres and Vesta, things we now call asteroids in the asteroid belt in between Mars and Jupiter, were thought to be planets until they realized, hold on, there's hundreds of these things. They're just a bunch of asteroids in a big belt. If we were going to call Pluto a planet, then hundreds of other things would have to come with it. There are lots of other things out in the Kuiper belt that deserve to be planets. Eris is about the same size as Pluto and is about 30% heavier. Makemake is also large enough to be a contender for a planet. Things like Haumea and Sedna. Hopefully, if it got made a planet, 2007 OR10 would get a better name. If Pluto is going to be called a planet, all of these guys and any more we find that are like it would have to come with it. Instead of having 8 or 9 planets in the solar system, we would have hundreds. And so the definition of a planet was changed. It had to be orbiting the sun, so it couldn't be a moon, so it couldn't be orbiting Jupiter or orbiting the Earth. So it couldn't be a moon, it had to be the largest object in the system orbiting the sun. It had to be in hydrostatic equilibrium, which is basically a fancy scientific term for round under its own gravity. So this would eradicate things like Vesta and other asteroids, which, although they're orbiting the sun, they're too small to have become round and planet-shaped. So Pluto's orbiting the sun, and it's round. What killed it? The third criterion that a planet has to meet to be called a planet is it has to have cleared its orbit. Basically, that means it has to be the largest thing in its orbit. All of the similar sized or smaller bodies, it has to have gravitationally cleared up, either eaten up and crashed into itself or ejected out of its orbit. As you can see, Pluto hasn't done that. And so it doesn't get to be a planet. And it was revised down to be a new classification that we call a dwarf planet, along with Ceres in the asteroid belt, which also got to be a dwarf planet. But also we've got things like Eris and Makemake, which also got to be dwarf planets. Things may change in the future. Currently, there's a suggestion that there may be another planet deep in the outer solar system. And if we find that, it may force us to redefine our idea of what a planet is again. That definition might include Pluto. And if it does, it means things like Eris and Makemake are probably going to come along with it. The problem is that there's no hard and fast difference between a small planet and a large asteroid. Because really there's only two types of thing in the solar system. In the solar system, we have these large lumps of mostly gas and smaller lumps of mostly dirt. Anything else is, there's going to be no hard and fast distinction between them. Even then, where do you draw a line between a small gas giant and a large Earth-like planet? It's a linear progression from one to the other. There is no hard and fast difference. So, New Horizons was on its way into the outer solar system, Pluto having recently been demoted to a dwarf planet rather than planet. What did we know about Pluto? Well, we knew it was roughly the size of Australia. It's got about the same surface area, though it's a bit smaller in all dimensions. It's a lot smaller than our moon. Until New Horizons got to Pluto, this was the best image we had of Pluto. This was taken with the Hubble Space Telescope, and as you can see, Pluto's only about 14 pixels across in this image. This was the best we had to go on. But there are some things you can see. You can see some parts of Pluto are brighter and whiter than other parts. Using a technique called spectroscopy, we can get an idea of the color of Pluto, and Pluto came out as a red color, which I'll talk a bit more about later. So Pluto was red, and we could see these light and dark features on it. So by taking several images of the planet as it rotated and using a computer algorithm to smooth out over where these light and dark patches are and then color them in, we could get simulations like this. So once you take those light and dark patches and smooth them out, add in the red color, this is what we think Pluto would look like. And it's pretty good. You can see this bright spot passing every rotation that we now know to be that big, bright, heart-shaped feature on Pluto with those deep, dark patches next to it. So pretty good for just a bunch of images that were originally just 14 pixels across. We also know that Pluto's moon is tidally locked to it. Now, our moon is tidally locked to us. That means one side of our moon always points towards the Earth. So we only ever see one side of the moon. This is why we have something called the dark side of the moon, the side that faces away from the Earth, and we never see it. Because Pluto and its moon Charon are more comparable in size than the Earth and our moon, they are both tidally locked to each other. As you can see in this animation, one face of Pluto always points to one face of Charon. You can also see that Pluto's tracing out a little circle there. Because Charon is so heavy compared with Pluto, it doesn't orbit Pluto. Pluto and Charon orbit their common center of mass. It's like if you get a friend and hold them at arm's length and spin around with them, you're not going to spin around yourself. You're going to spin around halfway between you and your friend. Pluto's a lot heavier than Charon, so this orbit is weighted towards Pluto, but it's still tracing out this little circle. Until Pluto was demoted, it had the distinction of being the planet with the largest moon relative to its own size. Since it got demoted, Earth has that distinction. We have the largest moon relative to our own size as a planet. Jupiter has bigger moons, but Jupiter's a much, much bigger planet, so its moons look tiny in comparison. As New Horizons before New Horizons went on its way, and while it was on its way there, the team used the Hubble Space Telescope to look for other moons around Pluto, and also any belts like Saturn's rings. If Pluto had rings like Saturn, they could be a danger to the passing spacecraft as it shoots by at 84,000 kilometers an hour. So in 2005, before New Horizons launched, they found Nix and Styx, which got their names because they were N and S after, Nix and Hydra, which got their names N and H after New Horizons. And then while New Horizons was on its way to Pluto, they found Styx and Kerberos. So again, named after things to do with the underworld, monsters like Hydra and Kerberos and the river Styx. Fun fact, you've probably heard of the three-headed dog Cerberus that guards the gates of hell. Kerberos is the Greek version, the ancient Greek version of that name, and it translates to spotted one. So the Cerberus, the three-headed hound that guards the gates of hell, is called Spot. Nice. In January of 2015, New Horizons got close enough to Pluto that its long-range cameras could start matching the resolution of the Hubble Space Telescope. And this is an image from about February in 2015. We can see Pluto, the main dot, and Charon, its moon, but it's still very, very pixelated. By April, the craft was still many hundreds of millions of kilometers away, but was close enough to be able to get its first color images of Pluto. In May, it was able to start resolving some detail. In June, it was really starting to get interesting, and good science was being done. And then July, rendezvous, closest flyby of Pluto. And so you can see these features I talked about before. We can see this big, bright, heart-shaped feature, which is made of nitrogen ice. And these dark, they're called maculas, these dark areas in the planet's south. There's an overall red color to Pluto, which I mentioned previously, and this is due to chemicals called pholins. Pluto has a lot of nitrogen and methane on it, and the nitrogen and methane react in ultraviolet light from the sun and cosmic rays from outside the solar system to create these reddish, tarry chemicals called pholins, which settle out on the planet's surface, giving it this overall red color. And the team got to name the various regions of Pluto that they saw. Now, this is one of the most comprehensive images of the names, and it says informal names for features of Pluto, because this image was from before those names got formalized. I said earlier that astronomers aren't allowed to name things anymore, and that's because they tried to name the planet Percival and things like that. They tried to name its moon Charlene. As asteroids were discovered out through the solar system, people were naming them after themselves and their friends and their pets. There's an asteroid called Mr. Spock that's not named after the TV character. It's named after its astronomer's cat. So the International Astronomical Union decided astronomers aren't allowed to name anything anymore. It has to go through a formal naming process. And so for a long time, these were informal names that the team put forward as suggested names for these parts of Pluto. And that's why they all have quite sensible names. They keep to a theme. You can see that the dark areas, the maculas, are called, have an underworld theme to them. So they're called things like Cthulhu and Krun and Balrog, to keep with the underworld theme of Pluto. The purple areas are various spacecraft, things like Hayabusa and Pioneer and Venera. They're all spacecraft, apart from Lowell, the person who funded the discovery of Planet X, Pluto. Clyde Tombaugh got his name splashed across the big heart-shaped feature called the Tombaugh Regio. And the theme is very much spacecraft and exploration and the underworld and literature as well. So there's a few writers. The green areas are craters, and you can see a few writers in there. There are also explorers like Drake. The blue areas are mountains, and you've got them named after people like Norgay and Hillary, the people who climbed Everest. In the heart-shaped region, so in the Sputnik planum, as it's called, the left lobe of the heart, again, named after a spacecraft. There are various islands and things that are named after spacecraft, such as like the Coleta de Dados, which is a Brazilian satellite, and the Columbia, one of the space shuttles which disintegrated and killed its astronauts. So these are all very sensible names, and a lot of them have been confirmed by the International Astronomical Union. So things like the Tombaugh Regio and the names for the hills, and the Cthulhu Regio, the Pioneer and Venera Terras, they have been accepted as the formal names. This is an animation of New Horizons flyby of Pluto. So we can see the moons shooting round as we get close to Pluto. So this flyby took about 9 hours at closest approach. And as you can see, we can only see at closest approach one side of the planet because its day length is 6 days long. And then we pass behind the planet so that the light from the sun shines through the planet's atmosphere and can be used to study the atmosphere of the planet. I'll play that one again. So as I say, you can see the little moons and shooting around, and Karen shooting around. You can see the big heart-shaped feature. They very much thought this was the most interesting side of Pluto, and so we'll time the rendezvous to get this really interesting side. We've got much lower resolution images of the other side of Pluto, but it's kind of not as interesting. If we zoom in, this is a simulated flyby from the images taken. Over to the left, we've got that big heart-shaped region. And over to the right, we've got the darker regions. And what I want you to notice is that on the white heart-shaped region, there are almost no craters, whereas out on the darker regions, there are lots and lots of craters. Craters are used to age different bits of the planet. If there are lots of craters, it means it's very, very old, because there's been lots of time for these craters to accumulate. Whereas if there are no craters, it means it's relatively geologically young. It's happened in the relatively recent geological past, and there hasn't been enough time for asteroids and meteorites to come along and pockmark it with craters. So the darker areas of Pluto have lots of craters. They're very, very old, potentially billions of years old. Whereas the light area, the heart-shaped feature, which is a big flood of nitrogen ice, has no craters on it, meaning that it's relatively young compared with the rest of the planet. It has happened in the last 10 million years or so, which is a big surprise because Pluto is a very small planet. It should have cooled off. It should have a solid core, not a liquid core like the Earth. And the Earth has a liquid core that causes volcanism, so volcanoes to go off and lava to spew out onto the surface of the Earth. Because Pluto is much smaller, it should have cooled long, long ago. And there shouldn't be the heat inside the planet to drive these processes to create these floods of nitrogen ice and things like that. So Pluto turned out to be a lot more interesting and a lot more dynamic than anyone expected it to be. Again, if we zoom in, this is a color image. So we're out over the Viking Terra off to the left-hand side of the heart-shaped feature. And we can see the craters showing that it's quite old. In the top middle of the image, there's a lake of nitrogen ice, and off to the right of the image, we've got a mountain range. And as we start panning along, it's thought that these mountain ranges might actually be water icebergs. So icebergs floating in that big sea of nitrogen ice, which we're now over, that have been pushed to the side and are creating this big mass of icebergs at the side of this nitrogen sea. Off to the right-hand side of the image, there's this iceberg or island floating in that nitrogen sea. To give it some perspective, that's about 1/3 to 50% larger than Rottnest Island. So that gives you a sense of the scale of the image here. In that sea of nitrogen ice, you can see sort of cracks and fissures running through it, showing that it's moving and pushing on itself and cracking. And you can also see it's got this weird skin-like texture to it, where these sort of dark little pits just everywhere. These are dark little pits that are about 50 to 100 meters across, and they are due to the nitrogen sublimating. Pluto's got no atmosphere, so the nitrogen doesn't melt. When it goes from solid ice, it goes straight to a gas. And so when the nitrogen ice sublimates, because it doesn't melt, it creates these pits. This is an image looking off to the right-hand side of the heart-shaped region, down in closer to those maculas. And what you see here, in the top of the image, there are mountains sticking up, and these mountains are 3 kilometers high, and they are made of water ice. Pluto is a very icy planet. Its surface is covered in nitrogen ice, and its geological features are made up of water ice. And down in the bottom of the image there, you've got a pockmark, which I'll talk a bit more about later. To the north of that, you've got this weird, it's called bladed terrain. Now on Earth, this is formed by things like wind and water, but there's no wind and water on Pluto. So it's still a bit of a mystery as to how these formed. And again, it's relatively young. You do see a few craters in this image, but very few on the bladed terrain, suggesting that it's quite young and has happened in the relatively recent geological past. I mentioned that pockmark earlier. I mentioned that there's very little rock on Pluto. The geology is mostly water ice. On Pluto, ice is rock and lava is water. These are cryovolcanoes that instead of spewing lava onto the surface of Pluto, they spew water, though they're dormant now or they're dead now. But in the past, they would have spewed water onto the surface of Pluto. So Pluto has ice volcanoes. As New Horizons shot away from Pluto, it turned back and saw the sun shining through Pluto's atmosphere and could see these bands of haze in the atmosphere. And if we zoom in, I don't know if it's coming up too well on your computer screens, but in the haze, there are some very faint features that are clouds. So Pluto has dynamic weather and is very, very interesting. It's a lot like Earth. In fact, this image of the mountain range off to the side of the ocean looks quite a lot like an image, a black and white image taken of Earth. This is from behind Pluto with the sun shining through the full atmosphere. This is a black and white image, but like Earth, Pluto's sky is blue. As I was saying, Pluto is very much made up of nitrogen ice on its surface with water ice and a rocky interior. And due to that remaining heat that's driving these activities, there may be a little bit of liquid water under Pluto's surface. These are the best images we have got of Pluto's moons. So Styx, Nix, Kerberos, etc. And they're the best we're going to get for a while because Charon was very much the main moon that was interesting. As you can see, there is this planet-wide canyon. I'll just move on to get the full image of Charon. You can see this planet-wide canyon. The south of the moon is pockmarked with craters, while the north is relatively craterless. What seems to have happened is that one half of the moon froze before the other, and that has shattered it and created this big canyon across the planet. You can see in the north there are some tholins that have spilled out from Pluto. And the team had a bit more fun naming the bits of the moon. They called that big dark deposit to the north the Mordor Macula. In the south, we've got the Vulcan Planum and the Tardis Chasma running through the Gallifrey Macula. You've got craters named after Leia Organa, Vader, and Luke Skywalker, amongst others. Now, again, these are informal names. Not a lot of them have been formalized. In Pluto, New Horizons' job wasn't yet done. After visiting Pluto, it shot out further into the outer solar system and passed by an object called 2014, but that has since been named Arakoth. And again, Arakoth is a very interesting object. It's red in color because of these same tholins, the same as happening on Pluto. And you can see what's happened is it's two smaller objects that have come together in a very slow collision. And so what we hope as scientists is that this can tell us about the very early stages of the solar system and how our planet and other planets in the solar system formed. So Pluto turned out to be a very interesting planet, a lot more scientifically interesting and a lot more dynamic than anyone expected it to be. And New Horizons' job isn't done. They're looking for more objects in the outer solar system that it can shoot past. So stay tuned. New Horizons has fuel to power it into the 2030s, so there may be more news to come.
Thank you very much, David, for that really exciting talk about Pluto and Sharon or Karen and Arakoth and every other crazy little lump of ice and dirt out there, which are really interesting things.
Thanks for having me. It's been good fun.
Now, listeners and watchers of all ages, if you have any questions for Dr. David, I'm sure he'd love to build on these questions, to answer them for you. And while you're thinking of those questions and writing them into the chat, I'm going to put a shout out to Marie and Lucy for all their great comments during that talk. Thank you very much, Marie and Lucy. We do appreciate you getting involved. But yes, any questions at all, we'll play Stump the Doctor and see if you can give a question.
Oh.
So David, what's your favorite thing about Pluto? What's the thing that you're like, oh, this is the thing you have to know?
The talk was so long because there's a lot of information I like in there. I love the whole story. Pluto has a very interesting story, from its discovery to its demotion to the story of New Horizons and what we discovered about it, that there was this huge swelling of love for this icy little world that nobody thought was terribly interesting. Mm-hmm. Because it's so interesting. It's got this big heart-shaped region, it's got flowing nitrogen ice and all this geology going on. It turned out to be a lot more interesting than anybody thought possible.
Absolutely. It's just one of those crazy things. The more we learn about the universe, the more we realize we don't know anything. We have to keep exploring it as much as we possibly can. Well, here we go. Okay, we have a question, I do believe. So, David, what's your personal opinion on Pluto in the planet versus dwarf planet divide? Were you disappointed when its status was changed?
Yeah, I was disappointed. So when was that? 2006. I was 16. Yeah, I'd grown up learning that Pluto was a planet. I was disappointed, but as I've gone on studying astronomy and astrophysics, I've realized, okay, this kind of makes sense. If we call it a planet, hundreds of other things have to come with it. But from a scientific point of view, there is no hard and fast distinction between an asteroid and a planet, and there is probably never going to be one. We're finding exoplanets throughout the galaxy, and as we study these more and more, our definition of a planet is going to have to be revised. So it's very much up in the air. A planet is a very arbitrary definition. So scientifically, it doesn't matter. Being a planet doesn't tell you anything about Pluto. It doesn't tell you how big it is, what it looks like, what it's made of, how interesting it is. It tells you nothing.
Fair enough. A question from Hamish. Is there any evidence of rings around Pluto? Did they find anything?
No, so they were very carefully looking for them, because if there was a ring, New Horizons would have shot through it and would have been destroyed by all these little ring particles that pummeled it at 84,000 kilometers an hour. So no, they didn't find any rings, and New Horizons, when it passed by, didn't find any rings either. It didn't find any new moons. The moons we'd found with the Hubble telescope, so Charon, Styx, Nix, Kerberos, Hydra, they seem to be it for the Pluto system.
And a question from Marie, where do you study and or work?
So it's up on screen now. So I studied at the University of Western Australia, which is a part of ICRAR, a contributor to ICRAR, and I currently work at ICRAR, the International Centre for Radio Astronomy Research.
Excellent. And from Ian, what's in the atmosphere of Pluto and how can it stay as a gas when it's so cold?
So the atmosphere of Pluto is made of mostly nitrogen, kind of like Earth. So our atmosphere is mostly nitrogen with a bit of oxygen and tiny little bits of other stuff. Pluto's atmosphere is mostly nitrogen, and that's part of the reason for the interesting dynamics that's going on the surface, because it's got all that nitrogen ice. As Pluto goes away from the sun, it's got a very elliptical orbit, so it gets closer to the sun and then further away. And so as it gets further away from the sun, the nitrogen freezes out onto the surface. And so there's a lot less atmosphere to be dealing with. And then as it gets closer to the sun, the nitrogen vaporizes and Pluto winds up with a much, much thicker atmosphere.
Excellent. Now we're going to have to wrap it up there. We're running out of time. So anyone who's watching or listening, if you have any questions, then you can always send them on Twitter to @ICRAR, so ICRAR, and we'll try and answer them. Or you can send an email to education@icra.org, and we'll send them to David straight away, fill his inbox with all the questions in the world. And in fact, actually, we do have one last question, I do believe, one that was just emailed to me. So there we go. This is a big one. Does the gravitational perturbations of Charon cause glacial disturbances and therefore generate heat and melt ice like a tidal meteorological system? Is it moon cyclical? Wow.
Great question. So for a bit of background for other people watching, so the moon, as it moves around the Earth, and the Earth rotates under it, creates the tides. So the moon pulls on the water. It also pulls on the Earth and flexes the Earth. The moons of Jupiter, as they orbit Jupiter, are flexed by the immense gravity of Jupiter, and that drives their volcanism, so their volcanoes and a lot of their geological activity. Pluto's got a very big moon. Can that be happening? Well, no, because they're tidally locked to each other. They're always facing each other. That's removed the rotation that creates that mechanism for flexing. So no, they're in very, very circular orbits around each other. And because they're always facing the same side to each other, that's removed any of this flexing. And so there's not any heat or energy to be gained due to the orbit of Charon/Charon.
Very good. So we're going to do one last question. Unfortunately, there's lots of other questions, but we just got to finish up pretty soon. So, from Greg, how does radio astronomy relate to this visual work?
Honestly, it doesn't. So, although we're called the International Centre for Radio Astronomy Research, we do branch out into other forms of astronomy. Radio is great and it can tell us a lot. It has a lot of advantages, like radio astronomy can be done during the day and through clouds, whereas ordinary optical astronomy can't. But to get a really good study of the universe and a picture of how our universe works and how our galaxy evolved and how particularly our solar system works, we need to do other forms of astronomy as well. So optical astronomy, infrared astronomy, gamma ray astronomy, X-ray astronomy. And so it all feeds in. And so personally, I'm not exactly a radio astronomer. I work on building the telescopes like the SKA radio telescope. But as part of my background, I teach astronomy and astrophysics, or have taught astronomy and astrophysics for about 5 years at UWA. And so I've taught about Pluto and Saturn and all the other planets. And we thought this would be a good one to kick off with. Everybody loves Pluto. It's a great topic.
Fantastic. Now, ladies and gentlemen, I want you to all make a very loud noise wherever you're watching this anywhere in the world, a noise to upset and scare your neighbors. Make sure they all want us tomorrow. Why were you yelling in your house so excitedly? So big gound of applause for Dr. David Gozzard. Thank you very much, Dr. David.
Thank you for having me.
And of course, from here on in, we'll be doing this every week with new people, 7:30, same bat time, same bat channel. Come on back. I think next time we'll be talking to one of our PhD students, Kat Ross, probably about black holes, but that may be wrong. But I'm mostly certain it's going to be all about black holes. So come on back then.